Hello, this is Mrs. Boots, and we're going to work the practice problems for our inverses lesson. So in problems 1 through 4, we're given the table and asked to find the inverse and graph it. So let's start by graphing what we have. I'm going to draw a little baby graph down here. I know that you've got a coordinate plane on your paper, which is great. Okay, so I'm graphing 2, 4, 4, negative 5, 6, negative 8, 8, negative 5, and 10, 4. And I'm going to connect those dots. So I have a nice pretty little parabola. So remember, when we do the inverse, we switch the x and the y. So 2, 4 becomes 4, 2. Then I would have negative 5, 4, negative 8, 6, negative 5, 8, and 4, 10. Now let's put those on our graph. So 4, 2, negative 5, 4, negative 8, 6, negative 5, 8, and then 4, 10. Again, connect the dots. Oops, I missed a dot. Okay, do a better job of connecting the dots than I did. So notice your graph, if you cut it diagonally, the line y equals x, you have a perfect mirror image reflection across the line. That means it's definitely an inverse and that we graphed it correctly. Let's look at number 2. Again, graph the original function we're given. So I have a point at 1, 1, at 2, 3, at 3, 9, at 4, 7, and then at 5, 1. It's kind of a crazy looking shape. Now let's do the inverse. Switch the x and the y's. Well, 1, 1 stays 1, 1. Then we have 3, 2, 9, 3, 7, 4, and 1, 5. Okay, so I'm still got 1, 1. The cool part is that's going to be in both our graphs. Now let's look. Now I have 3, 2, 9, 3, 7, 4, and 1, 5. Okay, again, if I drew my graph, drew a line at y equals x, it's going to cut through and give me a perfect mirror image. Number 3, again, we're just graphing our lines. So negative 2, 10. Negative 1, 8. 0, 1. 1, 4. 2, negative 2. And 3, negative 8. Okay. Now we got to switch our x and our y. So I would have 10, negative 2, 8, negative 1, 1, 0, 4, 1, negative 2, 2, negative 8, 3. Now let's put those on the graph. So at 10 it would be negative 2. At 8, negative 1. It's 1, 0. At 4, 1. Negative 2, 2. And then negative 8, 3. So again, mirror reflection across the line y equals x. If you graph it and you don't get the mirror reflection, then you did something wrong. Let's look at number 4. 0, 10. Okay, that's at the top of the y-axis. Then I have 1, 9, 2, 6, 3, 1, and 4, negative 6. We're going to connect those up. Okay, so now let's switch the x and the y. So I would have 10, 0, 9, 1, 6, 2, 1, 3, and negative 6, 4. Alright, now to put those points on the graph. 0, 10, so I'm starting on the x-axis. 9, 1, 6, 2, 1, 3, and negative 6, 4. Again, we have a nice pretty little graph that, if I could draw a straight line, would be a mirror image. Now they've given us a graph and they've asked us to find 3 points and then graph the new function. The easiest point to find is always one on the axis, so I have one here. It's 7, 0. Oh, did that backwards. That's 0, 7. And then the vertex is also easiest to find, and that's at negative 2, 3. Now all I need to do is find one other point. So I can get this point here or any of these points in here. I'm going to go for the top one. That's at negative 4, 7. So remember, we're going to switch the x and the y. So that becomes 7, 0, 3, negative 2, and negative 4 becomes 7, negative 4. Okay, so now let's put those on the graph. So 7, 0, 3, negative 2, and negative 4, 7. And we know there's a couple little dots in there. We're just going to draw our parabola so that it goes to the edge of the graph. And if we drew the line at y equals x, we would see that it is a perfect mirror reflection across the line. Next problem. Again, pick 3 points. I'm going to look for a point like an x-intercept, y-intercept. So I have 2, 0. Now, let's pick a point. Oh, wow, that's a little challenging. Okay, so I notice down here at negative 5, it looks like it's at 1. And I've got those switched. That should be 1, negative 5. And then the right side of the graph's a little hard, so I'm just going to pick 4. So at 4, it's about 1/2, just so that I can make my curve. So now let's switch those x and y. So I'd have 0, 2, negative 5, 1, and 1/2, 4. Let's put those in the graph. So 0, 2, negative 5, 1, so right about there. And then at 1/2, I go up to 4. So my curve's going to come around and then go up. Again, it is a mirror image across the line y equals x. Next problem. Again, pick 3 points. I notice I got a beautiful y-intercept here, so that's 0, 3. Then what do we do? Well, I got some little crazy bump thing going on there. So negative 1, it's at 3. That's interesting. Come down on this side. I see negative 2 is negative 1. I need a point on the other side, though. So I'm going to do 4 points on this one. I got 1, 5. Now, you could stick with just 3 points. It's up to you. But you need to do a minimum of 3 points for every graph. Alright, so now we switch x and y. So I'd have 3, 0, 3, negative 1, negative 1, negative 2, and 5, 1. So I'm going to put each of those on the graph. There's 5, 1, 3, 0, 3, negative 1, and then negative 1, negative 2. So my curve comes down, does a little loop-de-loo, and then goes out. Again, if you're not sure how to connect the dots, just connect them in order. It may not look as pretty as the original, but it should always be a mirror reflection across the line y equals x. Next problem. Same thing, still graphing. Let's find some points. I notice I have a starting point right here. Where's that at? Negative 3 is the y, 2 is the x. So 2, negative 3. It goes through the corner here, so that's 3, negative 2. Okay, do I have another point? Not really, but we could say right out here at 6 that it's at 1. We'll do that just so that we can, negative 1, so that we can get a full picture. So now switch your x's and y's. Negative 3, 2, negative 2, 3, negative 1, 6. Let's put those on the graph. So negative 1, we said it's close to 6. Negative 2 is at 3. And then at negative 3, it's at 2. And this is where it actually starts. And I curve up and away. Okay, if we're not sure about that, you have to remember the starting point, and you can always just circle it to indicate what it is. If I draw my line y equals x, does it look like a mirror reflection? Yes, it does, so it passed the test. Next problem. Look for some points. Okay, I see one on the x-axis right here. That's at 1. So I have 1, 0. I go up. We can go ahead and put that one in. What is that? 1, 3. At 2, I see it's up at 5. And then it goes off the graph. Okay, so we're headed towards 6. So I'm going to put 8, 6, just so that we know we're headed off the graph right in there. Alright, so now switch x's and y's. So I have 0, 1, 3, 1, 5, 2, and 6, 8. Now we get to put those on the graph. So 0, 1, 3, 1, 5, 2, and 6 goes 8. So we come along, and it curves up, and it stays at that positive 1 on the other side. So now let's draw our reflected line. Let's make sure that we've got it right, and look at that. Isn't that pretty? Looks like a perfect mirror reflection. Okay, this is the last graph we're going to do. Again, I see some intercepts activities going on here. So at 0, I've got 3. And at 5, it looks like it's at 0. I see I cross right in here, so that's at 4, negative 2. And then up here at x equals 6, we cross at 4. Now, why am I picking 4 points instead of 3? That's just so I can get a better picture. It makes it easier for me to draw. The more points you have, the easier it is to draw, but you need a minimum of 3 to make sure that you get some accuracy. So now switch your x's and your y's. So I'd have 3, 0, 0, 5, negative 4, 2, and 4, 6. Okay, let's put those on the graph. So 3, 0 is on the graph. 0, 5 is on the graph. Okay, negative 2, 4. That should be a negative 3. Wow. You guys didn't catch that. Okay, let me put that negative 3 in there. I knew something was wrong. Graphs are on opposite ends. So where is it? Yeah, it's negative 3. There it is. That looks so much better. Okay, and then, is that a negative 4? No, that is a positive 4. Okay, so we go to 4, 6. That's our last dot. And it's off my graph. So I'm just going to scribble it in up there above. So my line comes down, connects my dots. It helps if you write your points in order. Don't do it like I did and do them out of order because it confuses things. So it looks like I'm off a little bit, at least on the top side. On the bottom side it looks pretty good, but that may just be the shape of the graph. Okay? So now we're going to do the algebraic. Starting with problem 12, we're doing the algebraic. We've got to find the inverse. So my original equation is f of x equals 3x minus 8. Remember, f of x is the same thing as y. The first step is to switch x and y. So I'm going to write an x where there's an f of x and a y where there is an x. Now I just solve for y. That's easy enough. So the first thing I'm going to do is add that 8 to the other side. And we get x plus 8 equals to 3y. Now how do we get y by itself? It's kind of crazy, but yes, we divide everything by 3. So we get y equals 1/3 x plus 8/3. Now we could have written it all as one big fraction. That's okay. The last step is to do our inverse notation. So we have inverse f of x. Because we were given an f of x, we need to do inverse f of x. Is going to equal 1/3 x plus 8/3. You could have written this as x plus 8, all divided by 3. Either way works. Number 13. First step, switch x and y. So I have x equals 2/5 y plus 3. Okay, need to get rid of the 3. Remember, we're solving for y. So I have x minus 3 equals 2/5 y. Now this is where most people start to panic. Remember, to get rid of a fraction, you multiply by the reciprocal. The reciprocal means you just flip it upside down. So 2/5 becomes 5/2. So on the left-hand side of my equation, I now have 5/2 times x minus 3, and that's equal to y. So y is by itself. We have now found our inverse. So we write our inverse notation, f negative 1 of x, and that's equal to 5/2 times the quantity x minus 3. Yes, you can distribute the 5/2, or you can leave it just like that. Number 14. Switch x and y. So I have x equals 5y plus 9 all over 2. Well, I need to get rid of that 2 first. The 2 is dividing. The opposite of divide is multiply. So I'm going to multiply both sides by 2. On the left side, I'm just going to have 2x. On the right side, my 2's cancel, and I'm left with 5y plus 9. Now I can solve for y. So I need to subtract my 8, and I get 2x minus 8 equals to 5y. Okay, what do we do now? We've got to get rid of the 5, so we can divide everything by 5. You can do it individually, or you can do it all at once. So I have y equals 2x minus 8 all over 5. Y is by itself. So remember, now we do our function notation. And I have 2x minus 8 all divided by 5. That's my inverse function. Number 15. First step, switch x and y. Always switch the x and the y. So I have x equals y minus 4 quantity squared. The first thing I got to do is get rid of that square. How do I get rid of a square? I take the square root. So now I have the square root of x, and my square and square root cancel, leaving me with just the y minus 4. Got to get y by itself. Add 4 to both sides. So that 4 is outside my radical. So I have square root of x plus 4 equals to y. Now y is by itself. So we do inverse notation, f negative 1 of x equals the square root of x plus 4. That's the answer, or that's the inverse function for the f of x. Number 16. Start by switching x and y. So I have x equals the square root of y plus 8, and then there's a plus 5. Notice the plus 5 is outside of the square root. So we can move that over to the other side. So I subtract 5 to move it over to the other side. I get x minus 5 equals the square root of y plus 8. How do I get rid of a square root? That's right, we square both sides. We got to do the opposite. Make sure that you put whatever's on the other side of the equation in parentheses because you're squaring it all as one quantity. So now I have x minus 5 squared equals, square and square root cancel, y plus 8. Is y by itself? No. Got to subtract the 8. Do we subtract 8 from that 5? No, we don't. That 5's inside of a square, so the 8 is just going to be tacked on to the end. So now I have my function with y. Solve for y. Y is by itself. So I write my notation, f negative 1 of x, and that's equal to x minus 5 squared minus 8. So notice I started with a square root and the inverse function was a square. Number 17. I have a linear function here. So I switch my x and my y. The inverse of a linear function is another linear function. So I'm expecting to get a linear. Where do I start? I have that 1/9 on the outside. Need to get rid of that. So let's multiply both sides by 9. It's going to cancel on the right-hand side of the equation. So I now have 9x equals to 5 minus 2x. So we got to get rid of the 5. The 5's positive, so I'm going to subtract the 5 from both sides. So I now have 9x minus 5 equals to negative. Oh, wow. How'd we end up with 2 x's there? You guys probably think I'm going crazy. Let me change that to a y. Yes, we're solving for y, negative 2y. Okay, now that we've gotten rid of that confusion, how do I get y by itself? Divide by negative 2. Could I divide each term by negative 2? Yes. Or I can leave it all as 1. So my 2 and my negative 2 cancel, and I now have y equals 9x minus 5, all divided by negative 2. Remember, we write it in function notation, so I have my f inverse. I could divide each term by the negative 2 or just leave it as is. Number 18. Start by switching x and y. X equals 5 divided by y plus 1. Well, this is a rational. With rationals, we're going to get a rational as our inverse. So I'm going to put that x over 1 and then cross multiply to figure out what we're going to get from there. So this would be x times the y plus 1 equals to 5. Well, I need to get rid of the x. The x is multiplying, so I'm going to divide both sides by x. Kind of crazy. So now I have y plus 1 equals to 5 over x. Is y by itself? No. We got to subtract the 1 from both sides. So we get y equals 5 divided by x minus 1. Not a big deal, and yes, it is correct. So my inverse function is 5 divided by x minus 1. Notice I started with a rational, and I got an inverse of a rational. Number 19, let's switch x and y. So we have x equals 3 square root of y. Got to get rid of the 3 first. 3 is multiplying, so I do the opposite, which is divide. So x divided by 3 equals the square root of y. How do I get rid of a square root? That's right, we square both sides. Okay, so when you square a fraction, you square both the top and the bottom. So I'm going to end up with x squared divided by 9. That equals to y because the square and the square root cancel. So now I can write my inverse notation because y is by itself. And my inverse function is equal to x squared divided by 9. Number 20. Switch the x and the y. So I have x equals log of y over 2. Okay, so logs are a little tricky. Is the base written? No. The base is 10 if it's not written. And the y divided by 2, that's all inside my log, so I can't multiply by 2. But I can turn it into an exponent. Remember, we start with the base, go across the equal sign, and then come back. So that would be 10 to the x equals to y divided by 2. That's awesome. Okay, so now how do I get rid of the 2? That's right, we're going to multiply both sides by 2. Remember that 10 has an x attached to it, so we can't get 20 there. It's just 10 times the 2 times x to the 10 to the x, and that's equal to y. So my inverse function of the log is 2 times 10 to the x power. Well, that makes perfect sense because log and exponentials are inverses of each other. So now we have another log function. That's okay. Switch x and y. So it's log y, and then we have the minus 7. Note that the y is inside the log, not the minus 7. Again, the base is not written, so it's 10. So we can move that 7 over to the other side because it's not inside the log. So I have x plus 7 equals log y. To get anything out of a log, we do the inverse or the opposite. So we're going to turn it into exponential. So I have my base to the exponent equal to the argument. My base is 10. The exponent is x plus 7. And that's equal to y. Well, that's awesome. Now y is by itself. So I know my inverse function is going to be equal to 10 to the x plus 7 power. Number 22. Most people think that this is irrational because it has a fraction. But actually, it's linear because notice the variables are all in the numerator or on top. So I switch my x and my y. Notice the 3 is outside of any fraction, so I'm going to subtract that 3 and move it to the other side. So I get x minus 3 equals to y divided by 2. How do we get rid of that 2 in the denominator? You got it. We multiply both sides by 2. So now I have 2 times x minus 3. Make sure you put parentheses around that. That's equal to y. Y is now by itself, so my inverse function is equal to 2 times x minus 3. Number 23. Wow, this one's really different. I have an e in there. That's okay. The e is just an exponential function. Switch x and y. So x equals e to the y power minus 5. So 5 is outside my exponent. So I can go ahead and move the 5 to the other side. So I add the 5. I get x plus 5 equals e to the y power. To isolate an exponent, we have to turn it into a log. The opposite of exponent is log. So I start with my base, go across to find my exponent, or my argument, and then come back and set it equal to the exponent. So I would have a log with a base of e of x plus 5 equals to my exponent, which is y. What is log base e? That's right, it's just ln. So I have ln of x plus 5 equals to y. Now my y is isolated. So my inverse function, the inverse of x, is equal to the ln of x plus 5. Anytime I have an exponential with a base of e, the inverse is going to be the natural log. Last two problems. Number 24. Let's go ahead and switch x and y. What kind of function is this? It's a linear. That means we're going to get another linear as our inverse. So what do we do first? Add 5 to both sides. Okay, so I get x plus 5 equals to 1/2 y. That 1/2 causes people a lot of problems. But notice the 1/2, the 2 is dividing. And anytime I want to get rid of a fraction, all I have to do is multiply by the denominator. The denominator is 2. When I multiply, it's going to cancel. So I have 2 times x plus 5 equals to y. Now we know our inverse function. F negative 1 of x is equal to 2 times x plus 5. Last problem. Switch the x and the y. So x equals ln of y plus 2. Okay, is that 2 inside my log? No. If it was, it would have parentheses. So I can subtract the 2 and not affect the log. So I have x minus 2 equals to the ln of y. How do I get rid of a log? That's right, we change it into an exponent. What's the base of my log? E. So I have e to the power equals y. So e to the power of x minus 2 equals y. Is y by itself? Yes. So my inverse function, f negative 1 of x, is equal to e to the x minus 2 power. Does that make sense? My natural log has an inverse of e. Yes, that makes sense. This concludes all of our practice problems.